We're partway through the series in creating a custom door in GDL. Thus far, we've focused on the 3D, which is exciting and fun, but it's only part of the story. We now need to get into the 2D to make sure that your door represents correctly in all of the drawings in which it appears. It's not sexy, but it is critical to the production of tight drawings. If your door doesn't display correctly in all of its plan views, then it's not really that useful. In this episode, we're going to get started on that 2D, and specifically, I'm going to cover how to query the fill attributes from the building material that you've used, and also how to find out the view cut plane height so that your part can respond to the cut plane. There's actually more involved in the production of your 2D part than you might think. And it's often the simple stuff that can cause you the most grief. So let me clarify for you. I'll open our 2D script, and at the moment we've just got our project to command in here. If you refer back to episode 21, that's the command that we need to project the 3D correctly in 2D for a door, which is different to your normal objects. Now, because of the 8 placement methods, we need a transformation modification, which will be, we'll add nothing in the X, but in the Y, we will add what we need to account for the frame thickness and the window reveal side, which way the door is facing. Now, there's many more transformations that you can check for, given that the 8 different ways you can place a door, and if you want to look into those, they are under miscellaneous, doors and windows. We've got the 8 placement methods here, and then with all of the different tests that you can do for the various conditions. But I've found with the way that I place doors that this is the only transformation I need. Let's draw a frame first. Just create a subroutine after the end statement called frame. Set our pen and fill. The pen will be GS frame pen. The fill will be, sometimes these are what take the longest to figure out. The simplest things. What's the fill? Well, I want the fill to be populated from my frame building material. That's where I want it to get that fill type from. I don't want it to be set manually. We want it to inherit its value from the building material we use for the frame, yeah? So we've got a frame building material here. And as you know, building materials come with their own cut fill, where the fill pens are set. Well, we want to set it from this building material. Otherwise, if the user has to set it manually, 1, that's another thing they have to choose from a list, and 2, there can be a disconnect between the section fill and the plan fill, cut fill. We don't want that. We want to make it easy for the user and cohesive between section and plan. So there's a little bit of a process to this. We'll create an array, and this is just a made-up name, BM values. The dim is your declaration of an array. We'll set some default values. We only need 3 cells for this, or 3 array entries. So BM values 1, 2, and 3 will all equal 1. So that's just a default setting to make sure we don't get errors later in our script. So this is in our master script to make sure it's available in any script we use. Then we put in a request to function. And what this does is it runs off to the project database. The request type is for a building material info. So we're chasing down information for the building material we've used in our frame. The info we're after relates to the frame building material, which is my parameter right here, frame building material. So it will run off to building material info, looking for info on building material number 33. Specifically what it's after is the GS BMAT cut fill properties. Now that is a reserved parameter name. You have to get that one right. It's not made up by you or me. That's what it will look for, and then it will return 3 values, being the fill type, the foreground pen and the background pen. And N will be 1 or 0 depending on whether this request has been successful or not. Now I can say set my fill to be BM values 1, the first value of that array that got filled. So as I said, sometimes setting these attributes can be the most complicated part of your object. Now we want our plan representation to look something like this, right? Where the side jamb comes up and cuts through our view cut plane, we want it to be thick. Where that step is below the cut plane, we want to see it in projection. Except strictly speaking, this will be outside the wall hole. So there's a bit of complexity there that we need to account for. At this time, what I'll do is I'll just do jambs of this thickness, and we'll deal with the extra thickness when it comes up through the cut plane later on. So we'll just do simple jambs for now. Set our attributes. Now let's draw our frames. Now one way you could draw frames, if they were both the same, is to do a loop for I equals 1 to 2. But because in this scenario, there's the possibility that the frames will be different widths, I'll do them independently. Here's my axes, Y pointing out away from the wall, X pointing off to the left as you look at the door externally. So this will be our left frame, this will be our right frame. We want a poly2b command. It'll have 4 coordinate lines. The frame fill will be, we want to draw the contour, which is J1. We want to draw the fill, which is 2, J2. And we want to close an open polygon, which is 4, J3. So add all those up, it can be 7, or you can do 1 plus 2 plus 4. So you know exactly which flags you're turning on and off. For the fill pen, we want BM values number 2. And for the fill background pen, we want the third item that was returned in this array. What we'll do is we'll bring the axis over the width of our opening and bring it back the width of our frame. So that way, when we draw our frame, we can draw it the width we're going to do it now, or if it's going to be wider, we can just draw it out to the extra width. I haven't moved that axis yet, but I can do that in a minute. We'll just pretend that the axis is there. So it'll be 0, 0, 1, 0 minus GS frame thick and GS frame width, which will take it to that point. Let's see what happens. Excellent. Got our frame there. It's got its pens set correctly. Now we just need to put it in the correct place. We'll go A divided by 2 minus, and then at the end of our poly command, we delete that transformation. Add X is a 3D command. I want to add 2. Add 2 needs 2 arguments, an X and a Y. Trap for young players. There it is. Now we'll do the same for the right frame. There. Now what we want to do is find out whether these side pieces go through our cut plane. Your cut plane is accessible through your view settings, under settings, floor plan cut plane settings, and at the moment it's set at 1100. If our frame step height is set at 1100 or greater, we won't worry about the intricacies of the 45-degree intersecting with the cut plane. We'll just make it a little bit simpler than that. If it's 1100 or greater, then it's going to show as a wider frame. How do we do that? I'll start off with the logic in a simpler state so that we can understand what we're doing. There's a couple of different ways we can approach this. what I'll do is just create a temporary variable. And because I'm only going to use it very locally, I'll put an underscore in front. Frame width left equals, and if our frame step left is greater than or equal to 1100, then we want our left to equal, and then all we need to do is replace our GS frame width with our temporary variable. Let's test it, see if it works. Here we go. In 3D, let's drop it below 1100. Good. That's working. However, this is a bit clunky. 1100, that's hard-coded into the text. We don't want hard coding. We want it to read whatever the setting of the cut plane is. So how do we find that out? Well, under miscellaneous, global variables, general environment information, you've got a bunch of global variables that you can call on at any time. If we go down a couple of pages, we've got global cut planes info, and this will return an array of 4 values. And the first one is the cut plane height. Let's have a look at our cut plane settings again. We've got 1, 2, 3, 4 values, and the first one is our cut plane height. So that's what we're after. So instead of 1100 here, we'll go global cut planes info, and it's index 1. We'll save that. Have a look. So far, so good. Let's change our left hand to be 1050. And let's change our cut plane height to be 1 meter. So now when I change this, this should update. And there we go. It does. So that's working. Good. It's what we're after. And I'll just change this back to the convention of 1100. Right. So now that's done. All I need to do is the same to the other side. Frame width right. Okay. I'll test it. Right height is at 1200. I missed this. So I need to change those 2 coordinates. There we go. That's better. Good. Now when the frame isn't cut, we want to show that. So at the moment, that's our projection. Let's turn that off just to clear it up a little bit. Just so we can see what's going on. So when we've got our standard size frame, we want to show the extension of what happens down below our cut plane view. And it'll be hidden by the wall, so it'll need to be dashed. The way we should deal with this is to have a line type in here and a pen to deal with that hidden line below the cut plane. While I'm here, I will just hide this IFC operation. I'll hide these as well. And under 2D, so here's my 2 parameters I'm going to use, hidden line type and hidden pen. Where am I going to attack this in my script? Where will it fit logically? So I've got my test here where I test for the frame step being larger than the global cut planes or the cut plane height. That seems like a logical place to do it. So I set my frame width. If the frame step on my left is going through my cut planes, I'll draw a nice wide frame. Otherwise, I will draw my polyline, my dashed polyline. And if I move this transformation up to the top here, that means this cursor will be over at this point. So what I need to do is change my pen to my hidden pen. change my line type to be my line type, and draw my poly. Now, because I'm not going to use a fill or have curves or anything like that, all I need is a poly 2. The poly 2 needs a number of coordinates. I'll just draw 1, 2, 3. I don't need to draw this last line. I don't need to close an open polygon, and I don't need a fill. So in this case, what do I need my status to be? I just need to draw a contour. I don't need to draw a fill. I don't need to close an open polygon. So J1 is all I need. So frame fill will be 1, and my coordinates will be, X will be GS frame width. So the cursor will be here. We want to start there, go across. We go across 2 frame widths, down to there, back to there. GS frame width, start there. 1, 2, 3, 4. I do need 4 coordinate lines, and I'll finish at this point here. Now, some of you keywords stop. Oh, get rid of my comma at the end. Now, something funny is going to happen here, and I'll deal with that in a minute. Oops. That's not the funny thing I was talking about. What's going on? Why is it doing that? Too many parameters at line 34. Line 34, poly 2, 4, frame fill, 1, 2, 3, 4. If we look at the poly 2 has number of coordinate lines, frame fill, and only an X and a Y. No requirement for a status code. So I could do one or two things. I could get rid of these status codes, or I could change my command to a poly 2 underscore, which will have the same result. It just means I don't have to update all my script. Right. So there's my dashed outline showing the frame beyond. You can see it's impacted the rest of my frame as well. So what I need to do is I need to bring my pen, my frame, down below this statement, and I need to reset my line type to be solid. Now, I shouldn't be using a name. I'd say every template around the world has a solid line type, but I should be using an index because this can be renamed and break my object. It'll always have, or should always have, an index number 1 as your solid line type. There. You notice that this poly I've drawn here displays above the other things I've drawn, the axis, the filled polyline here. Now, the way it usually works is that it will display things in the order that you draw them. But lines have a higher priority. And because this has no fill, it has a higher priority, higher display order. To demonstrate that, if I add my frame fill flags here to be show a fill, that's the 2, and a 4 closed and open polygon, it's now displaying in the order in which it's been drawn. But when I get rid of those, it becomes a line as opposed to, in Archicad parlance, a fill, and it displays on top. Now, you can deal with that with a command called draw index, but for now, I'll just leave that. Now, let's deal with the right frame. And we'll keep our script structured the same way. So transformation, variable, conditional statement, setting our pen and our attributes. And so that's how I'll do it for the right frame as well. These will be negative. Now the logic here is a little bit clunky, where I'm essentially repeating code. And this is one way that you can go about it. Another way is you can get a little bit more clever with exchanging variables and going through a loop. But for the purposes of this tutorial, this will be fine. We'll reduce the height of this right one. And that's working as well. Excellent. We'll wrap this episode up there. Now, what did we cover? We learned some useful tips about getting the 2D representation working correctly. First was the building materials info request, where you can find out the attributes of your building material. Then there was the cut planes global variable, where you can find out the information on the current view's cut plane and have your object respond accordingly. Next up, more 2D. Now, don't be tempted to think that this is not useful and that's going to be boring and you should skip it. Your objects are going to look like rubbish and they won't get used if you don't get your 2D working properly. It's all part of a good functional object. Be there.